Okay, so we are going to see integration by parts. Okay, uh, the formula is udv equals uv minus integral of v du. Okay, let's take an example. The question is integration of x cos x dx. Integration of x cos x dx. So how do you do this one? Uh, First we need to understand what is u and what is v. We need to choose what is u and what is that. You can keep it as considered as v. So for that we have a rule which says I L A T A. Okay, this means I means inverse. This is logarithmic, and this is A is algebraic type of functions. T is trigonometry, and E is exponential. Okay, so first you have to look at your given function and choose in this order. You have to start off with whether you see I inverse, whether you see logarithmic, whether you see algebraic, whether you see trigonometric or exponential. Let's look at this question or the function, the different functions we have. We have algebraic, x is an algebraic expression and cos x is a trigonometric. So which comes first? Algebraic comes first. So therefore I have to choose u as x. Okay, so u equal to x. I definitely have to choose u equal to x. Rest of the ones you have chosen, this rule is basically to choose only u. Sorry, not for v. This is only u. Once you have chosen u, the rest of them is the dv. Okay, the other part, the remaining part, including the dx, you have to consider as dv. I'm going to consider this as dv equal to cos x dx. Okay, you write down this separately like this, and you can, to differentiate, you can put a line also. Maybe I'll just write down this in a different color just to differentiate. Okay, so dv equal to cos x dx. Okay, once you have chosen this one, this side whatever you have chosen for u, this you have to differentiate, or you have to take differentiation on both sides. So which means if I do that, I will get du. I will get du equal to dx. I'm taking differentiation on differentials, or you could say differentials on both sides. So I will get du equal to dx. Okay, fine, good. Then this side you have to integrate. For dv, okay, you have to integrate, which means if a integration of dv, you can also put a symbol. This step is not required once you get familiarized with it. So if integration of dv is v and integration of cos x dx is sin x?
Sin x minus it.
No, so plus sin x only. But okay, no need to put the constant of integration. You can just leave it as it is. Okay, so as you have understood, I'm just going to erase this. This step is not required. You can immediately put this one, v equal to, what is that? Whatever the v that you have found out, you can put that immediately. Okay. So can I need to erase this? I'm just erasing. Excuse me. Okay. It's not coming properly. Okay, so now we found the values of u and v. So therefore, integral of u dv. for integral of u dv. According to the formula, integral of u dv is equal to uv minus integral v du. So therefore, the given question is x cos x dx. X cos x dx, okay, which is this one we said it as u, x we said it as u, and this we assumed as dv. So we can use the formula. Okay, so this we just have to substitute the values of u's and v's. So if if I do that, u equal to x, u equal to x, okay, and v equal to sin x, v equal to sin x, okay, minus integral of v equal to sin x and du equal to dx. So that you have to replace here, du equal to dx. Okay, so we just got it. We just have to simplify this. Therefore, x sin x, this will not make any changes. This is fixed. You can write down as it is, x sin x minus of integral of sin x is minus cos x.
Minus.
Okay, here you can put c. So therefore, this x sin x plus cos x plus c. This is the answer for this integration of x cos x dx.
1 minus x square is equal to d. Root over 1 minus x square is equal to d.
Okay, before that we have to apply the ILIT, inverse logarithmic trigonometric algebraic. So to choose the u inverse, we have inverse function. So we have to consider u equal to sine inverse x. Okay, that means the rest of them are dv, which is dv is equal to x divided by 1 over x squared, 1 minus x squared under the root dx. Everything is dv. Now we have to, this side we have to differentiate, take differentials, and this side we have to integrate. So therefore this is equal to du equal to differentiation of sine inverse x is 1 over 1 minus x squared times dx. Dx also dv will come. This side differentiation of dv is v, and this we have to differentiate. So how we do this one? We have to make some substitution. We'll do some substitution here to do this integration. Basically we just have to integrate this side. So I'm going to do some substitution. So first let me erase this. So I put excuse me, I put okay, so I put 1 minus x squared. Okay, this let's say this is equal to t. I take differentiation on both sides, that is 2x dx, negative 2x dx is equal to dt, which means I can separate for x dx. X dx I can put it as minus dt by 2. Okay, so therefore the integration, I'm just specifically integrating this one. If I integrate this one, I can write down this as integration of x dx divided by 1 minus x squared in terms of integration symbol. This is equivalent to, after the substitution, I will get x dx equal to minus dt by 2 all over 1 minus x squared equal to root t. Okay, so this is equal to negative 1 by 2 dt divided by root t integration, which means I can easily integrate this using the power rule. I use the power rule, equal to minus 1 by 2. This is t power negative 1 by 2. T power negative, I can write down this as t power negative 1 by 2 dt, which is equal to minus 1 by 2 t power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. Plus c, it is not required here because it is, we are using in terms of integration by parts, so you can leave it. So then let's just clean this up. If we do this, this is negative 1 by 2 t power 1 by 2, positive 1 by 2 divided by, this is also positive 1 by 2. Okay, so this 2 and this 2 will get cancelled. So finally I am getting negative of root t. Okay, which means is equal to negative of what is that we have substituted, equal 1 minus x squared. 1 minus x squared. Okay, so just make sure that just to integrate this part we have to do all these things. This is according to integration by substitution method. So finally we know that integration of RHS is equal to minus 1 by square root of 1 minus s squared. So now I'm going to transfer it to this part. I'm going to write down here. After I integrate, I will get this side v equal to negative of 1 minus x squared, because this is the integration of this side. So now I'm going to apply the UV rule. Again I have to apply the UdV rule. This is UdV equal to UV minus integral of V du. We know this. Okay, so therefore given integration is x times of sine inverse of x all over 1 minus of x squared. This is what we are integrating. It is equivalent to UV. So we go back to our U is sine inverse x and V is negative of 1 minus x squared. So this is I substitute as it is, sine inverse of x multiplied by negative of 1 minus of x squared under the root minus integral of V. Our V is here, 1 minus of x squared, 1 minus of x squared, okay, with a minus. Don't forget that. V du is here, 1 by 1 minus x squared dx. So it will be 1 by 1 minus x squared all dx. So now you can clearly see that these two, we can cancel these two, this term, okay, this term I can and this term I can cancel. So finally let's just simplify this. This is going to remain as negative of sine inverse of, I can write down this as 1 minus x squared, okay, times sine inverse of x, and then this will, I have 2 minus, so which is a positive, term, and finally I have inside the integral I have only 1 dx. Okay, so therefore it is minus of 1 minus of x squared sine inverse of x plus x plus c. This is the final answer for the integration given in